Yes, so hello all, hello and welcome again. Mm, we'll continue with the builders today. So builder is something which is very important topic because when you go and create any objects, builder is a more viable alternative. So we can create the objects with other APIs as well, but most of the times you will use builders to create your objects. So far we are looking at the builders related to feature creation because we have seen associative arc, which is associative line, which is a kind of feature. Now we will do extrude builder today and most probably revolve builder as well. But builders are not just relevant for feature creation. When you go into assembly, you will be using builders because whatever objects related to assemblies, we can use builders as well there. In drawings as well, you will be using builder because you can go and create drawing views, you can create uh, the dimensions, any other annotations, even creating a sheet, you will need a builder. So builder is mm, one way of creating the objects, and it is not just related to the features or not just related to part automation. So builder is something across any object. So that's why we are spending more time on builders. Today we will see extrude builder, and we'll also see how you do reverse engineering. Reverse engineering means you don't know how to uh, you haven't used that builder yet, and you don't know how to develop all the script for that builder. So how you do reverse engineering if you are not aware about using or creating that object and you are using that specific builder first time. So how you do that? So we'll also understand the reverse engineering part. Okay, so let's start. Let me share the screen with you, and let me take you through the extrude window. Here inside home, I can go and create extrude, and let's understand what are different things we need to create extrude. So what we need to create extrude, obviously we need a sketch, obviously we need a direction, and obviously we also need the value for extrude, right? So and few more parameters. So the direction, the sketch or the curves, then value. These are what we need at least to create the extrude. It can be a solid body, it can be a shaped body. That depends on which sketch we have selected. But these are the parameters that we do need. Now let's get into the Visual Studio because now we already started using Visual Studio and we have also seen a lot of benefits of that. So here onwards, we will mostly code inside Visual Studio rather than journal editor. So let's start. I will open a new project. First, I will go and close this. So remember those 5 steps that I shown you in the earlier sessions. So how we use builder or how we write the code for using a builder. First step is defining the object itself. Second step is defining the builder. Third step is using create builder API and assigning that object variable to that builder. Fourth step is to uh, define all required parameters for the builder to work. And fifth step is commit the object. And then fifth step is destroy. Sixth is to destroy all the variable data of the builder. So these are the 6 steps, and these 6 steps remain valid for creating any builder. Let me find out the project. I do have a blank project, so I will rather choose to select that project, and from there we will start. Yes, this one. Okay, so you can even take the notes, these 6 steps, and because these 6 steps are not going to change at all, these will remain same. Okay, so now I will clean up this code. I have a session. I do have a work part as well. Now, I will go and define the variables for extrude object. My first line will be defining that object. So what I will do is I am going to create extrude feature. So I will define a feature variable. How I will go and define it? NX open dot. Now you see. Now we are inside Visual Studio. I think I missed to share this thing with you. This is called IntelliSense. IntelliSense means Visual Studio is giving me recommendations what I can uh, write next so that I can finish up writing my code quickly. So nxopen dot features. So here, if I am using this IntelliSense, more of a burden is removed from me when it comes to the typo mistake, also the lowercase, uppercase confusion. So that is very well taken care. You see, I have written features in small case, but I am getting the recommendation with capital F. And if I continue with the space bar, then my F is automatically made uppercase. So this is the beauty of IntelliSense. So features dot feature. Now you will say why I am using it features dot feature, not just nxopen dot feature, because feature represents the feature part. You can see that from the description here, and features represent the features collection. nxopen dot features. So you see that nxopen dot features is a namespace, which is features is feature collection. So I'm going to use feature object type, and that feature object type is available within features collection. That's why I have to write it like this: features dot feature. Feature represents a part, and feature is also a class. And then there are several APIs within this. We have seen what is difference between feature collection and feature. Uh, just a feature. So we already seen that in feature collection, we do have several builders related to feature, and in feature class, we do have the APIs related to accessing some information or modifying something within the feature object. So this is the difference. Okay, so I'm defining this feature type, and I will name it as extrude feature. So this will be the identifier. I will keep it null and then semicolon. Then I will go and define the builder. NX open dot features dot extrude builder. I can even get the information about this. It represents extrude feature builder. Then I will name it as extrude builder. So this is the next the second step I have. Now the third step is to use create extrude builder API and assign the extrude feature object. Though it is blank, but that doesn't matter. I need to uh, do that. That is step number 3. So extrude builder, this object I have defined is equals to work part dot features dot create extrude builder. Now I have used features again. Extrude builder is part of features, so that's why I have to use features dot extrude builder. Create extrude builder, then inside bracket you can see this is IntelliSense. This is giving me every information that I can use to write my code. It is even giving me information what I shall write into the bracket. So constructor, what are the parameters required and what is the type of those parameters, I don't need to take care. If I understood the concept of constructor, if I understood the concept of using API into the program, then IntelliSense is there to help me at every step, and I may not need to refer uh, reference guide that many times. Okay, now you can see this is the type of the object that I need to mention. NX open dot features dot feature. You can see here this is the type I need to mention inside bracket that I already declared here. So it is the name of this is extrude feature bracket complete semicolon. That's it. Step number 3 is done. I can go and add some comments. Step 1 is declare object. I am using comments so that you can also get this very well. Declare builder. Then use create builder API and assign object to be created from builder. So as this is commented line, we can see that in a green color. Comment means you already know this is not going to impact on your code at all. This is just for a description purpose. So we have created, we have done with the first 3 steps, which are more easy steps. Now the fourth step is more difficult, I can say. Step 4 is define all required parameters. Okay, so this is done. Now we have to define the parameters. Now we can go inside NX. You can see the first thing is section, right? So we can go and define section. So for section definition, we will need to what I can say, we will need to go and define few more few more variables. So there is a class that is called section. So that we need to initiate. So section, and then its name is section 1. Let's say I have to define it. I have to give some name to it. So this is defined. This variable is uh, section. Then inside section 1, I need to do something. First is work part dot sections. You can see we do have this sections collection. We have to use that because we have to define some parameters for section. So it is sections dot create section. First I have to go and create the section. What it do is it creates a section with single curve rule using given curve, edge or point. So I have to define this section, and there are three ways to define this section. So you can see here 1 out of 3, 2 out of 3, 3 out of 3. So there are three ways we can define section, or we can create section uh, in NX. So I can use this third option, which is where I go and define the tolerances. So actually these are chaining tolerance, distance tolerance and angle tolerance. We actually don't focus on these things when we create manually, but there are some tolerances and there are default values to these tolerances that we need to define. So you don't need to bother about this. This is kind of a standard line, and I can go and specify the tolerances. You can see this is in microns. So chaining tolerance, distance tolerance, and angle tolerance I have to define in a section. Then the next thing is section dot set allow entity types. So which selection I am going to allow in this selection in this section that I need to define. So what I can define is I can define the selectable entity types. So section dot allow types dot, I do have these options to allow curves and points, only curves, only points. So it makes sense to use only curves because point is not that relevant to create the extrude. So I will choose only curves and then semicolon. The other thing about section is section 1 dot whether I want to allow the self intersection. So that I will set to true. You can see this allow self intersection. We do need the boolean value inside, and I am specifying that as true. Okay, so section related things are defined. Now we'll go and define the extrude related things, extrude related parameters. So my builder is extrude builder dot section, and I have to define the section which is section 1. So I have already defined that section. Now I am assigning that section to my builder. So section 1 is defined inside builder. The next is extrude builder dot allow self intersecting section. So this I have to define now, and I will set to true. There are few more parameters in addition we have to define, which we obviously ignore or obviously overlook when we create extrude. Now there is also distance tolerance here in a builder. So extrude builder dot, you can see this IntelliSense gives me all of these options, all of these things that I need to go and define. Not every is mandatory, but it depends on which builder we are dealing with, and based on that we need to define those parameters, because we know that if we miss on any important parameter it may not work, right? So extrude builder, the next parameter is limits, which is very important to create the extrude. So start extend dot value dot right hand side, and in double quotes I have to provide the value. So I will provide it as 0. Start extend is 0. Then end extend extrude builder dot limits dot end extend dot value dot right hand side. I get this very ready made. Lot of my typing is, because of this is lot of typing is faster. So right hand side is 75 for end extend. It means how much I have to extend that extrude. So that is defined. Now the next parameter is direction, which is again very important parameter. Extrude builder dot direction. We do have direction here, and is equals to, I have to do something. I have to mention some direction, but I have not created any direction yet. Direction means I have to go and define the vector. So let's first define the vector now. Let's do that before this line. So we'll comment this line, and first we'll define the direction. So direction is the object type, nx open dot direction. I can write it like this: nx open dot direction, or I can also write directly direction, because nx open is already uh, imported in the first line, so that's why it is fine. Direction I have to declare, so I will declare it as direction1, and then I will declare a point and vector as well. So we'll declare point 3D, because we also need the origin point for extrude, so that's why we need a point as well. So point 3D is origin, the name of that I will use as origin, is equals to new. So this is the obvious way to define the uh, point. We already knew this very well. This is how we define the point 3D. Now similarly we'll define vector 3D, uh, and I will name it as direction dir, is equals to new vector 3D into bracket 1 0 0, because I want the direction towards x-axis in positive x. So vector is defined. Now I will assign these parameters to the direction, this vector 3D to the direction. So direction variable direction1 is equals to work part dot directions dot create direction, and inside this I can go and define origin, then direction, then smart object dot update option dot don't update. Okay, so these are the parameters I need. Actually, there are 25 ways we can define direction, and out of these, what we have used is point 3D, then vector, and then smart object. It is too much to go through all these 25, but you can go and check that even in, yeah, I think this is what we have used: point 3D, vector 3D, and smart object update option. So this way we are creating direction. Now you also see one pattern here. So when we refer to the collection, that time we have create related APIs. Features is collection, we have create builder. Yes, in directions, which is direction collection, we do have create direction. So this is a pattern you can understand. Okay, so direction is defined. Now I can go and uh, provide that direction to the builder. So extrude builder dot direction is equals to direction 1, because now direction 1 also has the origin and also has the direction assigned to that. Okay, so this is now assigned. Now next step is very important and very crucial, that is to assign the sketch object or sketch entities to our uh, extrude. So what I will do is, here I will need to initiate the loop. The reason is, uh, I need to cycle through all the objects and select all of them one by one, because if you see in the extrude, we have only one object as such in select curve, but there can be several objects in a sketch, and we want to select all of them. So that time I may need to use the for loop, because I want to select multiple sketch entities. What I will do is, for now, I will copy that for each loop function and will paste this here. And I can even go and tell you what exactly it is doing, because definitely you need to refer to other uh, video to understand more about for each loop. And I don't want to confuse you in between, because we are focusing on builder right now. So in short, I can tell you this for each loop is collecting all the entities from the work part irrespective of sketch. All the entities in work part it is collecting, and it is creating one array, one collection of the objects of those curves, and then uh, we are using that to create extrude. So for now, what I will do is, I will uh, modify this loop and will make it work on uh, work part dot lines, only lines. I am ignoring the curves which are circular. Sorry, curves means arcs. I am ignoring other things. Only straight lines will be covered. Okay, and I do need some objects here, because those objects are not defined yet. So I do need that object as well. So I will go and define that. Give me a moment. I have to define NX object, which is generic level object. We have already seen this type of object. NX object space NXO, I will name it as NXO, is equals to null. So this object I need, and now I do have this NXO name that I will use here. Uh, okay, so ignore the for each loop for now. What it is doing, it is picking up all those lines. This is something which is important for us to know, these few lines. So when you see extrude, there is very uh, important thing, which is this selection. So we do have various selection filters. Either we can select connected curves, tangent curves. As a design engineer, you might already know this very well. I am not going to spend more time on this. Single curve means you will select only single curve. But let's say if you have a tangency within different curves used in your sketch, then that time connect tangency will select all of those in one selection, right? So these are the different rules based on different selection criteria, and this helps us select the relevant sketch lines or curves in our extrude. So we have to also deal with this because this allows us the smart selection of the sketch, right? So this is what exactly is done here. So all of those actually called rules. So these are selection rules, and there are several selection rules available. So all those rules available under smart collection. So SC stands for smart collection, and this is the SC rule factory, and we do have several rules there. So I'm talking about this specific rule, or we have used this specific rule, which is one of the simplest of all different. So we do have tangent rules here. We do have other chain rule here. So there are several rules here, but this uh, rule based curve dump. So this specific rule is actually selects any entity without any criteria. So that is what we need, and we have used this rule, and that is given to selection intent rule because anyway we have to use any of the selection intent rule. That rule is defined here, and that rule is assigned. And once that rule is assigned, we have to provide all those sketch entities, selected sketch entities through this rule to the section. So these selected lines is that rule is created, and all the objects based on that rule are selected in these lines, and then we do need to add all those selected lines or selected sketch entities into the section, and that is what this specific line is doing, add to section. It adds the selection intent rules to the section with the option that we have choose. So we have choose the option of curve dump, and with that option it is adding that selection to the section. And now these are the parameters required. So add to section, we do have a constructor, and there are a lot of parameters required. So all those parameters are defined here. So if you see the IntelliSense now, so first we define the rules, then temp, which is the input object, which is the line in this case. Then this is just for the sake of requirement we are doing. NX object is a type, and NXO is the variable name for that we have defined. So we have used start connector, end connector, and then we also need the help point in the selection. So don't get into too many details. This is what is required for this API to use. And we have to use this API because we have to add all those selected lines into the section so that we can move ahead with the extrude creation. And for the sake of requirement of this API, we go and use all these variables. And what is the selection mode? Selection mode means we are going to create the extrude. It is also possible to use the builder to modify the extrude feature. But in this case, we are going to create that. And last parameter is a boolean, which is chain within feature. We can even go to NXO, this reference guide, and find out the add to section API help page. And you can go to read all of that. But that can add you some theoretical knowledge. That's it. If you don't want to get confused, don't spend much of time there. Just for the sake of understanding, remember that you need all of these parameters to define, and add to section is very important API we require to use for the extrude feature. Okay, fine. So we have done the extrude, and this specific function, this specific code block is going to select all the lines within the work part, irrespective of sketch. I'm talking about irrespective of sketch. It will select all the lines, and then those lines will be added to a section to create the extrude. Now, as we are done with that, all the parameters definition is complete. Now we can go and commit the feature. Now to commit the feature, I will go and what I will do is extrude. It is very simple. I have to find out extrude builder dot commit and then bracket and then semicolon. This is what is commit. Then which is the actually step number 5. Step 5 commit. Then step 6 is again a simple one, destroy. Extrude builder dot destroy. It deletes the builder and cleans up any object created by builder. That's it. So destroyed, we have destroyed the builder as well. Now with this, all 6 steps are complete and we are good to go. We are good to test this code, I mean. Now I can copy this entire code because testing this code when we are not want to debug, it is very simple. We can just copy this code, get into NX and paste this inside a journal. I will entirely wipe this out, paste this code, and let's see if it works. I do have some lines that this extrude can use. I think it will work. Let's see. When you start off NX first time and when you try to run a journal, it takes time because of because it is first time initiating that process. It takes time first time. Okay, I got an error. Commit is not happened because of something. Line number 51 has an error. So let me see what is line number 51. Commit is not successful. Okay, fine. Maybe I still think my code is right. So what I will do is I will delete all of these lines. Rather, I will go and create a sketch. I will create a rectangle. And now I will try this. Same problem. Okay. One more thing that I can see is I do want to create the extrude along X, right? Because I have given the direction X, but my sketch is on XZ plane. So it makes sense to create the extrude along Y direction, right? So I can go and change the direction if that is the reason for error. So we'll make this vector x0 and y as 1. Now it has created, right? So my direction was not correct, so I was not able to create the extrude. Now extrude is created. Now let's see if I change the sketch. Instead of all these lines, I will only keep one line. And now I will try to extrude this. Yeah, so it happens, right? So it is even extruding one line like this. Now I will go and add arc. And now let me test this again. You can see even I have added the arc in that sketch. The only line has extruded. No arc is selected. That is because the function that I have, that code block for each function, in that I have only specified lines, not arc. That's why my program is still picking all the lines. You can see here, it is all the lines. Now, let me create one more sketch. I will create it on same plane. And in this sketch, I will add few more lines and also add a circle, let's say, like this. Okay, and now I will go and play the journal again. Any guess what will happen? Still, obviously, it will create the extrude for the lines, but you can see it is irrespective of sketch. It has not only picked the lines from first sketch, it has also picked the lines from other sketch. That is because of the way we have programmed, we have written our code. We are not selected any sketch. You see in our program, we do not have any sketch selection kind of thing. We have selected all the lines in the active part. That is why we got uh, all the lines irrespective of any sketch that we have. Now let's see if I do it, if I change it and I make it arc. If I make it arc and then if I continue, let's see what happens. Uh, Sorry, arcs. I have to write arcs. Yes, end point is not okay. I have to change something as well here. Center point. Okay, so slight changes in the parameter I need to do. So after I done that, you can see the other extrude is only for arcs. The first one was for lines. If I hide this, you can see only arcs are now extruded. So this is how that filter works. This is just a very simple example of how the filter works. But there is a lot to do with all that selection intent rules, and uh, that is most crucial, or you can see complex part to understand for this kind of builders, extrude, revolve, all of that, where that selection intent is involved. But obviously, you don't need to bother about that. You don't need to take that more seriously because eventually all that complexity will be eased uh, for you as you go and spend more time, work more on such examples. You will be comfortable with that. Okay, so this is how you can go and create the builder. Now, the other part about other part on today's session is doing reverse engineering to find out how you can code the builder. So this is about extrude. Now what we will do is, let me first save this builder. Okay, so other part is you wanted to create that object using a builder, and you don't know what all are parameters you need to be cautious about. You need to like mention, you need to define. So that time it makes sense to use this method, which I call reverse engineering method. And this method is going to give you lot of inputs to create your builder. So let's do that. What you have to do now, I will clean up my part model little bit. Okay, so I do have this. Now what I will do is I will go to developer tab. First I will close my journal editor. I am going to record a journal. Record a journal. I am going to record revolve builder. And now you can see I can go and create the builder. Extrude, I will use revolve, and you have to very cautiously uh, take any steps while recording, because if you do something which is not relevant, that the code for that steps will also get recorded in journal, and your journal will be too long, and it will be difficult for you to identify the relevant code for you. So you don't need, so only uh, use the or the record the steps which are you required to get captured in your journal. Even if you rotate this model, this geometry, that will get recorded in your journal, and your code will be too long inside journal, so avoid that. So select curve. Let's see, I select sketch. It is not allowing me. Okay, because I think this is because of the intersection that we do have here. So I will cancel this. I will also cancel my recording. Will stop recording. Will modify my sketch. I will start recording again. Record. I will pick up the same file. I will override that. Then we'll go to revolve. Select curve. Curves are selected. Then I need a point and a vector. Vector will be, I need vector along Y or Z. Okay, let's see if it works. Then the point. Okay, I need, I think Z. Yes. Okay, all of the parameters are provided. Angle I will keep it as 360. Okay. Okay, done. Now I know which parameters I have defined, and the values for those parameters as well. Now I will simply go and stop recording, and I will click on edit button. Now what has happened? I got all the code for creating a revolve. Now As a layman, what you can do is you can go and play it, and uh, and you will see that the same revolve is created with the same parameters. But that is for layman. You are now going to be a knowledgeable and open developer. So what you must able to do is you must able to understand all the lines of code that is written here. You must also able to understand cleanup, and you will also able to modify this builder that can suit your requirement. So what has happened because of this journal recording? You got all the stuff that is required for your builder, and you can go on and work on this code. So and then you don't need to bother about, like, when you write something from scratch, you get lot of questions in your mind, which, how to define the section, how to add the sketch entities into section, which parameters to define, which type of parameters I need to define, which API to use. So all of that questions will come to your mind definitely, because you are writing from scratch. Writing from scratch is the ultimate level that you want to achieve. As you are here in this community, writing from scratch, from start to end, making that program work is ultimate achievement that you will have. But you will go there slowly, and uh, this is one of the stepney, or uh, the step that can help you get there, because as you go and improve your understanding, you will definitely get there. But it is no harm to take such help of the existing functionality that is there and create your code, but provided you able to modify it, you able to uh, use this code in a way that you want. If you manage to do that, even it is very well achievement, very good achievement. So definitely there is lot of code that can be removed from here. You can see the APIs like create scalar, create point, create extract from. These are all nonsense. This is not required, right? We know it from the Extrude Builder. At least create direction we need. That is fine. You will need this. Maybe this create system expression with unit not required. Uh, then this is actually selection intent rule, but this is without the for loop that we had. You can even convert this same in the for loop once you got the understanding about for loop. You can see here it is a rule. So it is feature rule which is used. And of course there will be add to section line as well. Yes, here you can see this is add to section line. The same kind of parameters are defined here. A rule, then the line, then the object, then help point, then the create mode, and last as boolean false. So it is more or less same as it is revolve builder. Few parameters are definitely different. There is commit, there is a destroy, everything is there. As you know that all 6 steps very well, you can definitely go and work on this code and make this a very clean, short, sweet, but the code that works, and the code that you know, and the code that you can also modify yourself. These are, I think, the lines of code related to the parameters definition. 360-degree is here, and I think somewhere direction is also there. Direction we have seen already. Create direction is there, right? So this is the code, and this reverse engineering can help you a lot for sure. If you don't know how to use that builder, how to create that builder, this is very well way. This is very good method to do the reverse engineering and find out what all are important parameters to create that builder. Okay, that's it. We are done for today. We learned Extrude Builder. Also, we learned how you can do reverse engineering. This reverse engineering technique works very well for builders. That's why I have emphasized on this. And that's it for today. We are done with today's topic.